All right, we're going to go ahead and look at our study guide. But before we get started, I want you to know a couple things. One, we actually filled in, this video is with the stuff that we filled in class, right? So the numbers were basically, you guys shouted out numbers and we put it in like ad lib, all right? So the numbers are class driven. And I will do another one of these with another set of numbers. So if you want to go ahead and check your work on your own, you can do that prior to the review. The second thing to remember is that this video is going to be crazy long. So what I want you to do is go ahead and do the study guide prior. I will go ahead and link this in the comments. So if you are at home and do not have the paper, you can go ahead and follow along. Do the problems first on your own and then come back and check your answers, right? So you're going to use this as a place to check your answers. If you did not get the answers correctly, then please rewind and listen to this, the explanation for that particular problem, and then move on and keep checking your answers. So this is not meant for you to listen to from start to finish. The third thing is my recommendation is that you listen to this 1.5 times speed. Apparently, when I'm explaining things, I speak a little bit slower. If that works for you, great. If it gets annoying, go ahead up to the settings and then go ahead and do the 1.5 times speed. All right, so that's there. Okay, so these are the types of questions that are going to be on it, right? So at school, we said that this was going to be 7, and this was going to, actually, let me put this in red for us. So this is going to be 7, and this was going to be 37 degrees. And this was going to be 6 and -3. All right, so I'll go ahead and start with those two. So the first one says the polar coordinates of point P are 7, 37. So this is that format r theta. What are the rectangular coordinates of P? All right, so here's where my process is going to be in red. If I want to find my x value, that's going to be r cosine of the angle. Because our angle here is in degrees, please make sure your calculator is in degrees. Your y value is r times the sine of theta. So anytime you change polar to rectangular, this is the process you will use. Okay, so let's go ahead and see how that's done. My x is going to equal 7 times the cosine of 37 degrees, and my y is going to equal 7 times the sine of 37 degrees. So let's take a look and see what that equals. If I put it in my calculator, my x is 5.59, and my y is equal to 4.21. So my answer for my rectangular coordinates would be 5.59, comma, 4.21. The alternative way that you could also do it, you might see it this way. Your test is in multiple choice, so I'm just giving you this as a background. You could also say, 5.59i plus 4.21j. Remember how we did the I hats and k hats with our vectors, all right? So this is probably all that you need. Okay, the rectangular coordinates of point P, are 6, -3. What are the polar coordinates? All right, so here we're going from rectangular to polar. And let's look at that process. So in order to do that, my rectangular is going to be the square root of my x value squared plus my y value squared. And then if it does ask for the angle, that's going to be the inverse tangent of y over x. Now there's that weird thing with your tangent. We always want to give the angle with respect to the positive x-axis. So with tangent only, so tan only, if you were in quadrant 1, you do nothing to your answer that you get on your calculator. If you're in quadrant 2, you're going to add 180. If you're in quadrant 3, you add 180. And if you're in quadrant 4, you add 360. Okay? Well, how do you know if you're in quadrant 1, 2, 3, 4, or 5. Remember, quadrant 1 has a positive x and also a positive y. Quadrant 2 has a negative x and a positive y. Quadrant 3 has a negative x and a negative y. And quadrant 4 has a positive x and a negative y. So looking at this point 6, negative 3, that is going to be a positive x and a negative y, so it's actually going to be in my fourth quadrant. So let's go ahead and take a look at how we solve this. So my r value is equal to the square root of 6 squared plus negative 3 squared. Please keep that square outside the parentheses if you put negative 3 in. Quite frankly, because you're squaring it, this would be the same as doing 6 squared plus 3 squared. So if you want to drop the negative, it's fine. Mathematically, it does not change your answer. So if it's easier for you to drop it, that's fine. So the square root of 36 plus 9, right? So that is going to give us the square root of 45, which is going to be approximately 6.708. So that's my r value. Now my theta is going to be the inverse tangent of my y, which is negative 3, over my x, which is 6. So when I put that in my calculator, I end up with negative 26.56. So the tangents will give you your answer with respect to the positive or negative x-axis. Depending on what quadrant, right, is what we're going to add to get everything with respect to the positive x-axis. So because my quadrant is quadrant 4, we just talked about that, I'm going to add 360 to it. And when I do that, I end up with the angle 333.43 degrees. All right, let's take a look at this next one. Vector V is 8i and 7j. Again, we came up with this in I have a typo. Vector V is 8i and then plus 7j. What is the magnitude of V, vector V? This is the equivalent of rectangular, right? So remember, I represents your x value and j represents your y value. And of course, k, we don't have it here, but that represents our z axis. So in order to go from essentially rectangular to just the magnitude or just finding your polar value, you're going to do the same process we did in number 2, okay? So you're going to take the square root, r is going to be equal to the square root of your x value plus your y value. And your I represents your x and your j represents your y. Okay, so that's our process. Let's go ahead and do it. So we have r is equal to the square root of 8 squared plus 7 squared. So that's the square root of 64 plus 49. And so when I go ahead and do that, did I not do that on my calculator? I did not. Hang on. I got to go ahead and do this. So the square root of 8 squared plus 7 squared is going to give us 10.63. Okay, and that's it. We're done. Now, why didn't I get the angle, right? Why didn't I go ahead and pursue that? It just asked me for the magnitude. Remember, a vector has 2 components. It has the magnitude and it has the direction. Right? So those are the 2 parts that make up a vector. So if it's just asking for the magnitude, all you have to do is solve for r. That's all it's asking for. And we did that. It's 10.63. Okay, 5 vectors are graphed on the coordinate plane. Which pair of vectors appear to have the same direction? All right, so I know there's not graphs here because we're just going to explain how to distinguish vectors that go in the same direction. And I know it's kind of like, well, duh, Mrs. Kroner, I know exactly what you're talking about. Think similar triangles. Okay, think similar triangles. So if they're going the same direction, it doesn't necessarily say that they're the same value. So just be aware of that. So if I have one going, let's say I have, we'll just call it vector V, right? And it's at an angle theta of 45 degrees. That 45 degrees is my direction. I might be able to distinguish that with however far it's going in the X direction and however far it's going in the Y direction, but ultimately it's looking at that angle. So if I want to find something that's going in that same angle, even if the vector is a different value, and let's say this is called W, as long as that angle is identical, you have the same direction. So same direction means same angle. Okay? So you're looking for two vectors with the same angle. If I have a vector that's going, say, 60 degrees, okay, and it is also a vector V, so it has the same magnitude as V, but it's at 60 degrees, that is not going to be going the same direction. It could potentially have the same magnitude, like your V values could still be the same, but direction is focused on your theta. That's the big thing to remember with direction. All right, so number 5, which graph, let's see here, which graph shows a vector, let's get those numbers in. We said 2, 2, and -5, -4. Okay, which graph shows a vector equal in both magnitude and direction? Ooh, magnitude and direction to the vector with an initial point located at 2, 2 and a terminal point located at -5, -4. All right, let's label these. This is x1, this is y1, this is x2, this is y2. You must label your starting point as the first. You must label your second, your terminal side as the second. You cannot deviate from that. What you're looking for is your change in x and your change in y. Actually, let me stick that in red because that's my process here. I'm trying to put all the processes in red, guys, so that you know what's happening, right? So I am looking at my change in x and my change in y. My change in x is going to be x2 minus x1. My change in y is going to be y2 minus y1. So let's go ahead and put these into practice and see what's happening. So delta x equals -5 minus 2. And delta y is equal to -4 minus 2. So -5 minus 2 is -7. -4 minus 2 is -6. Okay, so here's what this means. My object, okay, is going left 7 units and down 6 units. All right? So you need to find something that's going that same value. 7 units down, or 7 units left and 6 units down. That's the only way to guarantee it's the same direction and the same value. So if you're given a bunch of points, I would go ahead and just figure out what your delta x and delta y are for them. And usually you can tell from the x, like if you find your difference in x, and as long as that's the same, then you can go to y. If it's not the same, then eliminate that answer and move on to the next one. Okay? So that's your trick to that one. And you are going to have to look at graphs. But on that graph, you can easily make a triangle out of that vector, right? So if I have a vector that goes like this, I can easily see, okay, that's going over, let's say 5, so that would be -5, and then it's going up, let's say 3. That's +3 up. So you can take those vectors and separate them into the x and y components as a triangle. And as long as your triangles are the same triangle, not similar triangles, the same triangle, you will be the same. You will be in good shape. Okay, number 6. Vector is used. Let me go ahead and put the numbers in. 0, 8 and 4, 2. So again, pause these and see if you can do this. A vector is used to express a card's change in position or displacement by tracking its motion over a large area defined by coordinate grid. The car begins at 0, 8 and ends at 4, 2. Which of these expresses the car's displacement in vector form? Alrighty. So if I start, right, you're going to have a change in x, which is going to be x2 minus x1. You're going to have a change in y, which is going to be y2 minus y1. When you have those two new values, you have that change in x and change in y, then what you're going to do is you're going to find your resultant, which will be that change in x squared plus change in y squared, right? I mean, technically you could write it this way: x2 minus x1 squared plus y2 minus y1 squared, which is just the distance formula. That's all it is, right? And then to find our angle, we know that that is going to be the inverse tangent of delta y, your change in y over your change in x. And then we have to look at the quadrants to see which quadrant it's in based on the sign of that x or y to determine if I need to add anything to get the actual angle. All right, so let's go ahead and put it into practice. I have, so this is x1. Oh, it ends. Sorry, this is x2 and y2. It originates at 0, so that's x1 and y1. Right, so my change in x is going to be 0 minus 4, so it's a negative 4. My change in y is going to be 2 minus 8, which is going to be negative 6. So I have a negative x and a negative y, so that's quad 3. So I'm going to add 180 to my angle when I get it. All right, so how do I get my r value? That would be 4 squared plus 6 squared. And remember how I said you could drop the negative? So that's going to be 16 plus 36. So my r value, did I go ahead and do this? I did not. So now I have to get out my calculator. Thank you for your patience. So 16 plus 36. That's going to be 7.21, right? We're not going to get whole numbers because you guys came up with these answers. So that's my r, and then my theta, and I'm just going to keep going on this sheet here. My theta is going to be the inverse tangent of my y value, which is negative 6 over negative 4. Now those are going to cancel out, right? The negatives will. So the inverse tangent of 6 over 4 gives me 56.31 degrees. And that is that much from the negative x-axis. So I have to add 180 to that. And so when I add 180, because I'm in quadrant 3, I talked about it in question, I guess 2, I'm at 236.31 degrees. So that would be my answer for theta, and then r is that. So I could say in terms of r theta, it's 7.21 comma 236.31 degrees. Okay, so that would be my r theta way to describe it. And just keep in mind, like, they might just need the magnitude and, you know, southwest or northeast or whichever direction that you're going. All right, number 7. Let's go ahead and fill in those numbers in. Number 7, we said 7, 1. And point A was 1, 1. All right, so we did not do a terminal point B, and there's a reason. We're talking about a position vector. So this thing right here, anytime you see those brackets, it means it's a position. I apologize about the dog barking. It's a position vector, meaning that you know you're going to the right 7 and up 1. So your vector is going to the right 7, up 1, and then your actual vector looks like this at some angle. So if my starting point is at 1, 1, what I want to do is take that x value and add the 7. So I do 7 plus 1 gives me 8. So I know I'm at coordinate 8. And then I take my 1 that's here and add the 1 that's here. And that will give me 2. So 8, 2 is where I'm at. So essentially I just took 1, 1 and I added this change. So 1 plus 7 gave me 8. 1 plus 1 gave me 2. So just keep in mind your difference of your two, like your start and your finish, gives you your positional, your delta x, delta y. It gives you your positional vector. And if you're given a positional vector and where it starts from, you should be able to figure out what your terminal one is. Now, what if it gives you a position vector and a bunch of starts and finishes? Then what you're looking for, right, is because this is 7, that's your change in x is 7, and your change in y is equal to 1. So you're going to do x2 minus x1 on those coordinates and get a number, and that's your delta x. You're going to take y2 minus y1 and get a number, that's your delta y. And then if your x matches 7 and your y matches 1, then you know you have a match as far as abiding by your positional vector. So your positional vector is just your change in x and your change in y. Okay, there's page 1.